Hello guys, hope you all are doing good. So today we'll be talking about machine learning. So I think most of you might have heard this term machine learning every now and then, but many of us don't even know the meaning of machine learning or what is a machine learning system. What does a machine learning system mean? So basically, first let's get introduced to the meaning of a machine learning system. So a machine learning system is basically a program which learns from its experience with respect to some task T and performance measure P. So there is a task T and there is a performance measure P. I'm very sorry for my handwriting, but with time it would improve. And there is also an experience E. So basically, a machine learning system is any system for which performance of the system on any task increases as the experience increases. That is, suppose we have defined a system wherein we are determining whether an image is a cat or a dog. So what we are passing an image and we are determining whether it is a cat or whether it is a dog. So as we pass in more and more number of image and our model learns through the images, it will be able to determine whether the image is of a cat or a dog. That is, the task here is to determine whether an object is a cat or a dog. Performance measure would be the accuracy, and there are many other metrics that we'll talk about later. And the experience would be, with time and more images will keep on passing, the experience of this machine learning system for the learning experience would increase with time. So this is basically how would you determine whether a system is a machine learning system or not. So we can split a machine learning system in task, we can provide an experience, and we can track its performance using some metrics. So this is how we define a machine learning system. Now machine learning systems are generally of two types, but there is one more are generally of three types. Now machine learning systems are of generally three types. So let us talk about those. So this is a machine learning system. So there are three types of machine learning system. One would be supervised. We'll talk about what does these terms mean. Another one is unsupervised, and the third one we'll talk very late in this course because it requires some fundamental understanding of machine learning of self-supervised and of some supervised and unsupervised. It's called semi-supervised, and one more come, it's called self-supervised. So I'm sorry I mentioned two, but there are actually four. So initially these two were the main, and probably will be focusing on these two initially. Then later in this course we'll talk about these two, which are much more detailed and require much more understanding of machine learning system in order to understand how we are going to do these two types of approaches. This is the basic understanding of what is a machine learning system and what are the type of machine learning systems. Now the next thing we'll talk about is what is this supervised. So the first thing of a machine learning system is a supervised machine learning system. So what is a supervised machine learning system? So let's talk about it. So what is basically a supervised learning algorithm, and how would we define a supervised learning algorithm? So here we give a data set and the program fits the data according to the chosen fitting. So there are multiple types of fitting that we have, and we provide the data and we fit the data according to the fitting. So basic understanding, if you want to know if a system is a supervised system or not, so we know that there is a data that is provided. Now a data contains of features which are the input values and the target. So like the example which I gave previously of the image, and then we are determining whether it is a cat or a dog, then this image is the input, or also called as feature, and this cat and dog are basically the output. That is what you want to predict. So this is called the output, or also called the target variable. So whenever you are provided for a training data, so you will require a training data in order to train your algorithm. So if your training data consists of both features and also the targets to it, that is, you have suppose 1000 images, and those, for all those images, you know that what is that image, individual image. So do you know the 1000 labels for each image as well? That is, all your data is labeled. Then this whole system is basically known as the supervised system. That is, you have the knowledge, that is, you have the information of each input, and you know what does that input belong to. So let us get the example of it. So the first supervised algorithm that we'll be talking about is called regression algorithm. What is a regression algorithm? Those people who are from engineering background might know what does a regression algorithm, or generally known as a linear regression, what does that mean? So let us take an example of house price prediction. Okay, so house price prediction, we know that the generally, however, there are multiple feature reasons to it, but we know that with the size, or with the area of the house, the price of the house increases. So suppose this is this y-axis is the price of the house, and this x-axis is the area of the house, area in square feet. Okay, so we know that as the area of the house increases, the price of the house increases. But what is the relation between this? So suppose we have these values here. This is one data point, and this is another data point, this is another data point, then probably this is another data point, and suppose this is another data point. Then how do you fit the data point? Is there any relation you see between price and area? So suppose if we are trying to fit a straight line between this, how would the straight line look like? This would be the straight line, right? How to determine which straight line fits? How would you determine that? So basically, how the machine learning algorithm work, it basically finds that line such that the distance, this is the true value, and whatever is the x point here, this is your predicted value, such that the distance between these points, the points on the line and the point, this is the ground truth points, is minimum. So this is the fitting of the line such that the distance, this cumulative distance, is minimum. So this probably could be the best fit or the best fitting line, and for this particular line we would have an equation, and we all know that the equation of a line is represented by y is equals to mx plus c. So this way we will have an equation for it. But we see that this is not a perfect fitting. What if we have some other kind of a fitting for this? So suppose instead of using a straight line as a fitting, can we have a fitting like this? Not this, sorry, drawing is very bad. So if you see, this is a circular, or also called as quadratic, like a second degree curve. And you see this is even a better fitting line as compared to the straight line, because you see these distances are pretty low on this curve as compared to the distances on this line. So this particular curve is a better fit as compared to the straight line. So this is a quadratic fitting. So this one we knew is a linear fitting, and this one is a quadratic fitting. And as we keep on increasing the degree of the degree, so what is a quadratic fitting means? Here the y value is dependent on the second degree of the input value, that is 2 degree. There could be some bias added as well as some variables multiplied to it, but this is how it is: x square, and there could be a 1 degree plus x, and even this x could be 0 plus c. So this is a form of a quadratic equation. Now this is something that we know, that this is the regression algorithm. That is, you have a relationship between area and price. You know the values at what area, what is the price, and this particular training data you are trying to fit any algorithm, a regression algorithm, and you are trying to find the best fit out of it. So this is a regression algorithm wherein the data which we have is as you can see that these values are like if we suppose we take an example, if the area is 500 square feet, here the value could be suppose $1,000, and similarly $2,000. So we have continuous values here. But what if we don't have a continuous values? Like, there's an example, we'll take another example wherein we'll talking about what if we have a problem statement wherein we need to determine whether a person has breast cancer or not. So here the answer would be yes or no. That is, the target variable will be either yes or no. So how would you determine? So suppose we have a relationship between this, and this is a relationship, and I should have used lines. So if the tumor size, suppose this is the tumor size, this axis shows the tumor size, that is the increasing of the tumor size, and this is whether the cancer is malignant or not. Okay, so this line is 1, which means yes, and this particular line is 0, which means no. Okay, so we see a relation here. This could be the relationship, like this is one point and this is another point, this, and then probably as the size of the tumor increases, there is high chances of it to have, I drew it in the wrong place, so there is a high chances that a candidate could have a malignant cancer. So here you see the target variable is actually having only 2 values. So these types of problems are known as, what are these known as? These are known as classification problems. That is, we have the data points, we have the x values, that is tumor size here, and we need to classify it whether it is a malignant cancer or not. So these types of problems are known as classification problem, and here we see that it is a binary classification problem. We could have multi-class classification problem as well, and these are it's a very common problem statement that we face in a day-to-day career. So what if instead of tumor size, we could have had one more input feature, that is age? How would you show it? suppose we have one more feature, age. This is let's remove this from here, and this particular axis is age, and this particular axis is basically the tumor size. And we see that this is the relationship. So we see this is the sort of relationship we are getting. That is, here with circles we are representing that the cancer is benign, and with cross we are representing that the cancer is malignant. And when we plot it with tumor size, that is for a certain tumor size and at a certain age, this is the cancer, it was a benign cancer. These are the data from cancer patients, and this is the kind of pattern we see. Let's take this color, or let's take some other color. Okay, so this is the type of pattern you want to see. Now you want to determine how would you classify it. So basically you have to determine a boundary between this, that is a separating boundary between whether a cancer is a malignant cancer or it is a benign cancer. So where do you see the boundary between these two? Probably this would be the boundary. Right? It is not a perfect fit, as you see that one case of malignant cancer is here and the one case of benign cancer is here, but this would generally represent the data that we are looking into. Like generally anyone in the age group with a tumor size up till this is generally a benign case, wherein these are most probably belong to the malignant case. Okay, so this is how, with as the number of features increases, this space also increases. This is a 2D space, then it would, suppose there were 3 features, then it would become a 3-dimensional, 4-dimensional, 10-dimensional, and hundreds of dimension. And in this similar manner, there would be a dividing boundary that will help us determine what is the boundary or the threshold which will let us know whether it is a benign cancer or a malignant cancer or any other type of a classification problem. Okay, so this is also known as, this is called the binary classification problem, and the previous one we talked about was called linear regression. This is called logistic regression. Okay, this type of fitting of line is called as logistic regression. So this was all for supervised learning. That is, there are other supervised learning algorithm as well, but basically for the supervised learning we have understood that the supervised learning is basically wherein we have the x data and also the y data, that is the target variable corresponding to the input data, and so that we can map it on any of the ML algorithm and we can train a system so as it can learn based on the information that we are passing in and determine what is the decision boundary for different classes in case of a classification problem, and also determine the best fit in case of a regression problem or linear regression problem. Okay, so that is it for today. Hope you all enjoyed it, and tomorrow I'll introduce you what is an unsupervised learning algorithm, and we'll give you a deep introduction to a linear regression model and how the whole mapping and how the whole learning happens. We learn tomorrow. Thank you all. If you all like this video, please share, subscribe, and also let your friends know that there is something that is going to touch upon all the ML fundamental topics from theory up, and we'll go from theory to the practical implementation, because I believe for an ML practitioner, instead of going through the project, it's more important to know the underlying concepts so that you can know and you can make decisions when the problem statement becomes very, very tricky. Okay, fundamentals are really important, be it any domain. So similar case for machine learning, knowing the fundamental is always good. Thank you all, and see you next.